want to just find the x value. It is the same formula, and you can use the same formula. But because you're going to do this so many times, you're going to say cross multiply and get the x by itself. So every time I give you an area and you need to find that x value, you're going to look up that area and find the z-score associated with it. Of course, we're going to give you the mean and the standard deviation. You're going to use the same formula, it's just transformed. So now all you have to do is plug it in, you get the x. Plug it in, you get the x. Do I need you to know how to transform it? No, I'll give you this formula. It is the same formula. It's very easy to use. So let's see how we're going to do this. As soon as you see one go, it will make sense. So a veterinarian records the weights of cats treated at a clinic. The weights, again, are normally distributed. Oh, this is my normal curve. With a mean of 9 pounds and a standard deviation of 2 pounds. So far we used to do this. We put the 9 in the middle, we added 2. We subtracted 2. Same thing, right? Then we used to give you an x value and say, what is the z-score for a cat that weighs 10.5 pounds? And you put it into your z-score formula, and you find out what the z-score is. Now, we're going to say, find the x values, the weights, of cats that have corresponding z-scores of these guys. Let's head to this one first. So now if I tell you what the z-score is, you come here and find the z-score, and you plug this into your formula. Okay, the z-score is 0. We can obviously see what the weight is going to be, right? What's the weight when the z-score is 0? So let's see if that is true when we use your formula. So we take the z-score, which we gave you, we times it by the standard deviation plus the mean. Ah, isn't that an x of 9? You can see that from your chart as well, because we're smack in the middle. This one, not so easy to see. 1.96 falls between what two z-scores? 1 and 2. A little closer to 2, right? Now I need to know that x value. My board's just a little bit off. It's not on that line, it's just a little left of it. So it's not quite 13. I don't know where it is, but it's not quite 13. So I use my formula. My z-score is 1.96, my standard deviation is 2, and my mean is 9. All I gotta do is throw that entire thing in my calculator. If I throw that in my calculator, I get 12.92, and round it to one more decimal. If you like, round it to 1 decimal, 12.9. So did we say it was going to be real close to 13? Yep.
Excuse the interruption. Brianna Vasquez to the main office immediately. Brianna Vasquez to the main office immediately.
If we used your z-score formula and we wanted to find the x, it would work the same way. We put your z-score in here. Say x minus the mean, which is 9, over the standard deviation, which is 2. So don't you cross multiply first? You cross multiply and get 3.92, I think. Then you add 9. Comes out the same thing. We just transform the formula so that you don't have to walk through all those steps every time. It is one formula only. So let's try this guy. What happens when it's this? Negative 0.44 should come here somewhere. So my weight should be somewhere between 7 and 9. We just used to do it the opposite way. We gave you the weight, you found the z-score. This one's so much easier to use this formula. So now you don't have to worry about which way to subtract, you just plug it in. Negative 0.44 times my standard deviation plus my mean. Throw that whole thing in your calculator. Throw that whole thing in and you get 8.12. And you can go one decimal place. And didn't we say it would fall somewhere between 7 and 9? It's almost halfway, isn't it? It's almost like close to the negative 0.5. So we're just reversing what we did. So we transformed your formula. So again, I wouldn't have to go here and do this again and plug in my z-score, plug in my x value that I don't know, cross multiply these guys, add 9. I don't have to do that every time. I transform my formula once and I use this. Good? Okay? You know it's going to get a little tougher than that, but right now, let's have you try this. You try it through. Oh. This is normally distributed. Come on. I'll give you the formula. The good news is, I will give you that formula, even though it comes from your original formula. I will give you that one, because some kids panic over how am I going to get x by itself.
Oh my God.
Ah, yes, way. Okay, pull out your mean. Pull out your standard deviation and find the scores that have a negative z-score of negative 2.3, a z-score of 3.10, and a z-score of 0.58. Find those for me. You know it's going to be a little bit tougher. They gave us the z-scores. So the next step is they're going to give us an area. We now know how to find the z-score, so we can find the z-score and then use the formula. So now we're going to pull the whole thing together. Okay? So, scores for California Peace Officers Standards and Training Tests are normally distributed with a mean of 50. Again, they told us normally distributed with a mean of 50 and a standard deviation of 10. So we're going to make our chart. I still want you to sketch for me because you need to see where those values are falling. A mean of 50, we add 10. Then we subtract 10. I like when they make them even numbers. An agency will only hire applicants with scores in the top 10%. Do they want the high scores or do they want the low scores?
I'm gonna say it's the high scores.
High scores. They want the highest of the group. They want the top 10%. So where will I find the top 10%? On the left side of the graph or the right side of the graph? The right side of the graph. Somewhere out here, I need this to be 10%. Now, we just found our z-scores for this. They want to know what is the lowest score that an applicant can get and still be in that top 10%. So I'm in charge of looking at test scores. All I want is that cutoff point. I want that cutoff because anybody that scores less than that, I'm not going to look at their application. Anybody that scores that or greater, I'm going to look at their application. That's a cutoff. That is the best way to use your z-score formula. The best way. So if we have to use this to find this x value, I need to have a z-score. I can't use 10%. That's an area. So first thing I need to do is find a z-score. And that should be, I would say, somewhere 1 point something high, close to the 2, at least in the 1 point something high, right? Some part over here somewhere. So how do I find the z-score associated with 10%? Top 10%. Sarah. Okay. Sarah's looking to the left, and Sarah said, well, if she's on the right-hand side and it's 10%, she can look up point 90 to the left. Okay, let me get there. Okay, so she looked up point 90 because she said, 1 minus that. I'm lazier, so I say, could you do this for me? 1 minus my point 10. I wanted 90%, but I just didn't feel like subtracting it. I said, I'll let the calculator subtract it. I'm on a standard normal curve because I want the z-score. And I'm going to paste. And I find my z-score to be 1.28. Does that make sense to me? Yeah. Another way to look this up, if I looked up the negative of this, if I just looked up 10%, because I know my curve is symmetric. So all I have to do is look at 10%. I don't need the rest of that stuff in there. When I look this up and I see negative 1.28, I know it's the positive 1.28. That's another way to look it up. If you want to keep it on the positive side, that's fine. Now you have a z-score. You cannot put 10% in there. You have to have the z-score. You have the standard deviation. You have the mean. Now you can find the x value. Now, when we do this, this is 62.8. Okay. I need them to be in that 10%. So look where I am. I'm coming across, I'm 62.8. I need to round to the nearest whole number. Well, no. I need to round into that shaded area. I realize it's to the nearest whole number with this one. I need to round into 63. But if they had gotten a 62.1, if this was a 62.1, if I round to 63, they didn't make a 63, did they? If that's my cutoff area. So since I need to round into that shaded area, this guy, I'm going to have to round him into that area. He did better than a 62, but I need him to round into the 63. Okay, because he did better than a 62. I just have to round into my shaded area. Okay. So here is my cutoff. So I am the person in charge of this. Every test that comes by, if they're less than 63, I don't look at them. They're not my top 10%. I need them to be my top 10%. Does that make sense? Just watch the rounding, because you want to round into that shaded area.
Where does the 62.1 come from?
No, I just made that up.
Oh, okay.
Just to say, where would you round that?
Alright.
Where would you round that? We could do the bottom 10%. Maybe we want 90% of the field. We just want to know where the lowest 10% is. I don't want the lowest 10%. Depends what you want. Generally, when they look at SATs, this is how they look at your SATs. A college doesn't individually examine your SATs and say, that's a pretty good score. A college says, in the SATs, I want the top 40% of the kids. I want the top 10%. If I'm like Harvard, I want the top 5% SAT scores. So every year, of course, the standard deviation changes, the mean changes. So every year they calculate this, and they probably just take the top 5%. Tell me what my cutoff is. If you didn't make that cutoff, they send you back. Say, don't want it. That's why sometimes a college will say, your grades look great, your transcripts look great, but you didn't make my cutoff for the SATs. Could you take it again? I need you to get there 2 more points. So that's sometimes while a college will ask you to take the SATs again. Or say your SAT grades were low. They don't tell you where the cutoff is, of course. They just say they were a little low. take them again. You want to be in that percentile that they want you in. So this is why we use to find an X, which is important to find this. Does it make sense? Okay, let's try another one together. In a randomly selected sample of women ages 23 to 34, the mean cholesterol level is 181 milligrams per deciliter with a standard deviation of 37.6. Assume that they're normally distributed. Oh, normally distributed? I make a curve. If they're not normally distributed, I stop right there. I can't do anything with it. If it doesn't follow a normal distribution, done. Problem is over. Okay? So my mean is 181, and my standard deviation is 37.6. So I'm going to put my 181 here, and go up and down, and I'll probably just go down on this one because they're going to ask us just for the bottom part. Find the highest total cholesterol level a woman in this age group can have and be in the bottom 1%. I want that person to be in the bottom 1%. So the bottom 1% is on what side? The left side, right? Somewhere really, really small out here somewhere. This is 1% of my data in here. Now, I'll just do these out so we can see where this falls. Minus 37.6. So this is 142.4. This is 104.8. And this is 67.2. Okay, so now we want to know who's in that bottom 1%. We want the X value. So we write our formula out. We have our standard deviation. We have our mean. We don't have our z-score. We have an area. So the first thing we do is inverse norm, and we find your z-score. How do I put this in my inverse norm? What should I put in here? Good. 0.01. Move the decimal 2 places over. It's a very low number there. It's a very small amount. And I round this to 2 decimal places. So my z-score is negative 2.33. I just plug that in right there. Negative takes care of the subtracting part because we're always adding. But now this becomes negative. So we're actually subtracting. Now how we subtracted as we went to the left? We're still subtracting because your z-score is negative. So now your x value would be 93.39, but you want to round down into that shaded part. So our x will be at 93. Make sense? Monday we'll try some more of these. I know I'm running out of time. This carries like 45.
Usually I know.
The road